In this video we'll talk about acquisition of the photos for photogrammetry. Kudos to Evgeny for his visit to the zone to help us out with the theoretical part of the course. So first of all, is everything scannable? Not quite. There are objects that are simply not suitable for photoscanning, like transparent, glossy, dynamic surfaces, or impractical, like complex objects. Let's start with the objects that are close to impossible to photoscan, like the objects that are made of glass. The problem with such surfaces is that there are no common points in different camera angles of this object, and that really complicates the process of finding the common points across all the photos. And either the object becomes invisible or explodes. Well, some photoscanning software is clever enough to interpret the changing reflections on the object as noise, and thus you still can get a pretty usable object. But it's much safer if the object is covered with some diffuse dust in the first place. Well, maybe you can help the process a little bit by spraying some diffuse material over it when it's possible. But generally, the highly glossy and reflective objects aren't really suited for photoscanning. It's because the reflection shifts its position across the camera angles, even across the camera angles that are relatively close to one another, and chances are that the result after reconstruction will be deeply disheartening, to say the least. Once again, the more diffuse is the surface of the object for photoscanning, the better. So from that perspective, I would always prefer the car, which is actually covered with the bird excrements. It makes it so easier to scan. It is amazing, honestly. Then the dynamic objects like the water are also no-no. Who would want to scan water? But anyway, anything that changes in between the frames, in between the photos rather. Even the changes in lighting in between the shots can provoke the problems with geometry. It will look pretty much very bad independent of the software, so it's much safer when the object is entirely static. If it's not supposed to be a 4D scan capture at 60 frames per second like in this Pixel Light demo, but that's the whole different story. Aggregates and porous volumes like trees, grass, bushes, you name it, are also not suitable for photoscanning. Not only it requires an enormous resolution and spatial fidelity to properly capture the strands of grass, it just makes very little sense from the perspective of how 3D assets are used and created in general. And it looks like a blob usually. Well, to be fair, I have seen some very impressive demos like this point cloud tree demo by Gerbot on Sketchfab, and I can imagine some intriguing use cases, and definitely I don't want to discourage you from experimenting. But anyway, usually scanning such objects make very little practical sense. Talking about practicality, there are types of objects, like the complex object with lots of thin parts, that technically can be scanned, but it would require an enormous effort to scan it properly. This bridge is a good example, I guess. It's a complex structure with lots of repeating parts, and it looks a little bit, how should I put it, non-solid. And non-solid, complex objects that occupy their bounding box in this porous kind of way are tedious to scan, let's put it straight. There are photoscanning artists that break this rule with no regrets, like Romain Rouffaé. So with lots of practice and effort, that should be doable. And to prove it, we have captured our own motorcycle for the course. It's not as detailed, but as a proof of concept, I guess. But if you have a choice, there are easier objects to scan. Alright, the minimalistic and boring modern architecture and other featureless objects make no sense to scan, so we will put them in this category as well. It is simply much easier to do it traditionally in 3D. So we have taken a look at the objects that are either not suitable for photogrammetry or simply impractical. And to conclude this video, let's name the perfect candidates for photogrammetry. First of all, it should be a solid object that at the same time is both opaque and rough, like this roadblock. Then it would be cool if it was something unique that can't be recreated in 3D just as easily. It also won't hurt to keep the object static and make sure it has lots of texture and detail, like this derelict building that we will be reconstructing throughout the course. Or this dirt surface, for example. That being said, if it doesn't have aggregate and porous things covering it entirely. So old abandoned buildings, weathered barrels, crates, bricks, ground materials, everything that we love so much in this abandoned post-apocalyptic setting, everything fits greatly the paradigm of photogrammetry. Thanks to Eugenie and Nick for providing the photoscanned examples. My name is Gleb, and I will see you in the next video, how to photoscan different types of objects.